Okay, so this is 8.2, the normal distribution. It's the main topic of the unit. Yesterday we talked a little bit about histograms. It's basically a bar graph for continuous data. If the shape looks like a bell, then it is called the normal curve or Gaussian curve. It is normal because such a shape happens very frequently when collecting data. It is called Gaussian because of a man named Gauss who was the genius behind it. All right. So what are the properties of the normal distribution? It is symmetric and unimodal. Unimodal means there's just one bump, right? Symmetric means the left side looks like the right side. Mathematically, what does symmetric mean? It means that the mean, the median, and the mode are the same thing, right? The mean, median, mode are all. It's not skewed like yesterday we talked about positive skew and negative skew. It's not skewed to either direction. The normal distribution is the best model for statistical data, especially if you have lots of data, like, not a sample size of 10, but sample size in the thousands and the millions. And then, a lot of times for the data that you collect, it ends up being the normal distribution. The mean, median, and mode are all equal. There is some variation, of course. The means are different values. Like you could have a mean of 100, you could have a mean of whatever, several million, depending on what variable you're measuring. And the spread could be different. You could have a big spread or a wide spread. So this would be spread out here. This would be a high. Remember, we didn't talk about the measure of spread, but we introduced it a little bit in the introductory correlation assignment, and so the measure of spread is called standard deviation. So a high standard deviation, or sigma, would be where it's spread out more, right? This would be a low standard deviation, or sigma, and it's less spread out. Okay. There is some standard property of the normal distribution, and we talked about this in that correlation assignment as well, that 68% of the data lies within one standard deviation of the mean. Right? So that's the mean. That's standard deviation. That's the mean plus one standard deviation. This is the mean minus one standard deviation. That's 68%. In actuality, it is 68.27. And there is, from the mean minus 2 standard deviations to the mean plus 2 standard deviations, that width is 95.5% of data. That's actually 95.45% of the data. And the last one is within 3 standard deviations of the mean, it's 99.73. If you want to be more accurate, you can use those numbers. Okay. So that's what people have found. There is a mathematical formula for the normal distribution. We'll talk about that in a second. So that's what I just talked about. And again, you can't get the probability of one particular value. You can only get, for continuous probability distributions, you can only calculate the probability of the outcome falling between two values. Right? What's the outcome of any particular? What's the probability of any particular outcome? Do you remember from yesterday? 0. Which kind of makes no sense, but that's just the way it is when you're working with continuous probability distributions. Okay, that's no real note taking on this page. Let's go to the next page. All right. Everyone have this? All right. There is a formula for the normal distribution. Do you want to know what it is? Here it is.
Yes.
All right. It's kind of complicated. So it involves, you have to know the standard deviation of the population, but then surprisingly, it is being multiplied by the square root of 2 pi. Now, that's kind of surprising. And this is all times e. You guys have taken calculus. You guys know what e is?
Yeah.
Okay. All right. Isn't this a fun formula?
It's really long. Is that to the power of negative 1 over 2?
Yeah. So this curve, how do you generate this curve? The formula for this curve, this is a function, right? It passes the vertical line test. It's a function. What's the formula for the function? That's the formula. If you graph this, you get this. Okay? And depending on what the mean and the standard deviation are, you get either like a skinny one or a fat one, you know. So, but that's the formula. Do you need to worry about this? No. This is just for fun, so don't worry. You don't need to memorize this, okay? Everybody okay with that? So don't freak out about that. That's just a mathematical formula. I don't even know where they get it. Like it just popped out of the book. So, all right. What are the constants in this formula? Sorry, what? So E is a constant, yes. E is a constant, and does anybody roughly know what E is?
1 point. 2.7. No,
2.73.
I got 2.17.
2.71.
I think it's 2.178. Is that right?
It's 2.17. 2.718. 718.
Okay, somebody look it up, but I think it's 2.178.
Sorry, I put on my calculator. It's 2.718.
Oh, 718. I have it backwards then.
Yeah.
2.718. Okay, thank you for that clarification. Okay, so that's a constant. Is there any other constants?
Pi.
Pi, and pi is, you guys remember that one?
3.14.
3.141, whatever. Or 159, dot, 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 dot. Okay, those are constants. So what does the function actually depend on? If you take out the constants, which are just numbers, what are the variables?
X. A.
Well, it's the function of x, so we're not going to worry about x because x is the variable. But what variables do you need to plot the function? Like for every value, x is of like when you have y equals mx plus b, right? X is the variable. Y and x are the two variables. What does the formula, the shape of the graph look like?
Slope and the y-intercept.
Yeah, it would be m and the b. So what's the equivalent of the m and the b here? So let's forget about the x is what I'm saying. So
The standard deviation.
So it depends on the standard deviation. And what's the other one?
I know what the other sign is, but
What the heck is this?
mu.
U, yeah. Which is the
average.
yeah, the average.
All the numbers.
The mean, the average, yeah. So it only depends if you have some data. You can generate this function because the pi and e are just constants. The only thing that's not a constant when you're generating this is the standard deviation. The standard deviation and the mean. Those are the only two things you need to generate this thing. Okay. All right. So normal curves only need the above information. Sigma, which is sigma and mu, standard deviation and mean, to create them. Since you can find this information for any data, you can create a normal curve for any data. All right, so I'm going to actually talk about the standard normal distribution. But before I talk about the standard normal distribution, I'm just going to come up with an example, and it might be a little bit an example of just a real case scenario of some data, and then I'm going to create a second one where I'm creating the standard normal distribution over here. So I'm going to create two graphs here. It might be a little tight on space. If you want to refer to another page somewhere, you can do that. But I'm going to stick it in here. But again, it's going to be a little tight. Okay. So here we go. Let's take an example of some data, and I'm going to say it's marks on a quiz. All right. And I'm taking this exactly from that external video I posted yesterday. So I'm just taking her data here. So And let's say it looks something like this. You had a mean of 70% and a standard deviation of 8%. Remember, these marks on the quiz are in percents, right? So this is mark, this is percent. And what's on the left-hand side, I'm going to put probability density. We talked about probability density yesterday. All right. So this is our value for x, the mark. X is the mark. So we're going to have a bell shape if it's a normal curve. We're going to assume that the marks on the quiz were spelled something like that. Let's say it looks something like that. So what we're saying is the mean was 70 and within one standard deviation. What's one standard deviation below 70?
Below 170?
Yeah, below 70.
Wait, sorry, the graph doesn't make sense. Isn't it supposed to be like pulled to the right or pulled to the left? Because it's marks on a quiz.
Yeah,
And it's the example that you used yesterday.
So we're going to have a whole bunch of marks, right? Let's say we had a really big class. Let's say there was 200 people in the class. The average was 70. The mean was 70, so most people got 70. But then some people got more than 70, some people got less than 70. And if you got this data saying the standard deviation was 8%, that means
that's 8%, then it's
so 8%. What's 70 subtract 8?
62.
So between 62% and 70 plus one standard deviation would be 78%. In here, you would expect to get 68%
Of the population?
of the 68% of the data. Not a mark of 68%, but 68% of the values, right? And then, so that's one standard deviation. So, and two standard deviations would be something like that. So between two standard deviations, what would be, if you go down another one standard deviation, what would you get from 62?
54.
54. Yeah. What did I write? Why did I write 59? Oh yeah, it's 54. It looks like a 9. And then this one here would be 86, I guess.
86.
And that would be 95% of data. And then one more, I guess. One more standard deviation. Oh, it's hard to show this one. Or why don't we just leave it at that? All right. So 68% within plus or minus one standard deviation. 95% plus or minus two standard deviations. Okay. So let's talk about what the standard normal distribution is. When we do questions, we're always going to convert the actual data that we get into something called the standard. So this is an example, and we're going to do the standard normal distribution. Over here. What does that mean? Well, instead of showing values, the actual marks, we're going to show something called z-scores. I haven't explained what a z-score is yet, but so just bear with me. Okay, it's going to be the same bell curve. Okay, and all we are to convert this graph to this graph, we are going to artificially make, instead of the mean being 70, we're going to make the mean equals 0. By definition,
why are you making the mean equal 0?
That's what we always do for the standard normal distribution. Okay, the mean is always going to be 0. We're just bear with me. There's a reason for doing this. So by definition, the mean is always 0, and the standard deviation is always going to be 1. So that means you get the same curve, but then you're going to have 1 here. And then here we're going to have 2, and then whatever, 3. Over here we're going to have -1, -2, -3. And these are called z-scores.
So those are the marks?
Those are not the marks. We're going to convert marks into z-scores, and I haven't told you how to do that yet. Okay, but for example, a mark of 62, we know that this is, if you get a mark of 62, you're 1 standard deviation below the mean, right? So a mark of 62 corresponds to a z-score of -1. A mark of 70, when you're right on the mean, corresponds to a z-score of 0. You're right on the mean. A mark of 78 corresponds to a z-score of 1. You are 1 standard deviation above the mean. So we're not going to use the actual marks. We're going to use, to do calculations which I haven't explained yet, we're going to use z-scores, but all marks can be turned into a corresponding z-score. Okay? So again, this is going to be, this is like +1 sigma, this is +2 sigma, this is +3 sigma, this is -1 sigma, this is -2 sigma, -3. Right? The standard deviation is 1, so the mark, your z-score is 1. You're greater than the mean by 1 sigma, by 1 standard deviation. So here's the formula for z-score, and the z-score formula is right there. It's just here they use so it's x is your value, whatever value you're talking about, whatever mark you got in the quiz, minus the mean divided by the standard deviation. And you can see it's kind of hidden, it's kind of buried right there. This right here is z-score. It's in the formula. Alright, so let's just write down, it says z-score, but I'm just going to say it's pronounced z-score. If you want to say z-score, that's fine. I don't know what the Americans do, but let's call it z-score. It's just easier to say. So a z-score is only applicable to a particular data point. So a z-score of a data point equals, that's the formula.
So how do you spell Z?
Well, I don't know if it has Z-E-D. Z-E-D? That's how you pronounce it, anyway. Z-score. So what is it? This is the actual, you input a data value. In our particular case, it was a quiz mark, right? You subtract the mean. And you could end up with a negative number or a positive number. Positive number, you're going to be above the mean. A negative number, you're going to be below the mean. And this is just a standard deviation. So basically all it represents is z-score represents distance from your mean, distance from the mean. In terms of standard number of standard deviations away from the mean. That's what I should have written. Z-score represents the number of standard deviations from the mean. All right. That's so an example. Example. I know it's a little tight on space here. A mark of 70. Z-score equals 0. Example, mark of 62 equals a z-score of -1, right? 62, z-score of -1. Oh, sorry. All right, everybody okay so far?
Yeah.
All right. To do problems, we're going to use the this graph, not so much the original data. We're going to use z-scores to calculate probabilities. Are you ready?
Sure.
All right. Did everyone print out this thing?
So where do we get that? Do you want us to print that out too?
Oh yeah, I wanted you to print that. It's in the book. It's page 606 and 607 from the book. So if you can flip to the book, you can do that too. Okay. Page 606 and 607 from
So
the
let me
book.
just get my textbook.
Yeah. Just if everyone can get the textbook, page 606 and 607, you will see this chart. You need this chart to do all these questions. Okay. All right.
So what if we don't go back to school? Do we keep our textbook?
Oh no, we need the textbooks. Oh, wait a second. Oh yeah, those are the old textbooks. I don't even use the old textbooks. No, we have to collect them. You guys also have like physics books, chemistry books. We need those back, eh? They're not yours to keep. So somehow they'll be. You'll come to school and you'll drop them off, I guess. Yeah. All right. So what is this chart? This chart shows you the area. Remember, the area corresponds to the probability. The area up to a certain z-score. Like if your z-score was here, what's the probability? The area up until that point. So let's take a look at it. So if your z-score was 0, so here's your z-score. If your z-score was 0, your probability would be 0.5. Which makes sense, right? You're right at the mean. That would mean if your z-score was 0, 50% of the area would be here, and then 50% of the area would be above that point. So we're only looking at the area below the z-score. So, right? So what does these numbers over here represent? How do you think you use this chart?
You use it to determine the 0 score.
The z-score, yeah, the probabilities. So these are all probabilities of a value of probabilities associated with a particular z-score. But it gives you decimals. These are, if you look at the top, it's 0.00, 0.01, 0.02, all the way to 0.9. So if you want to,
What does that represent?
so what this represents? If your z-score was let's say the z-score was negative 1.23, you would go to negative 1.2, and then go over here to the third column. Sorry, the fourth column. Negative 1.2, and then adding the 0.3 would be there, and you would.
Oh, wow, that's
and
cool.
then you would calculate that number. Use that number. So the probability of a value being below a z-score of negative 1.23 is 0.1093 from the chart. Okay, we'll get more expertise using this. Are we good? Okay, let's do our first question. All right. Where's the next page? Is this the next page? Okay, here's the next page. Complete the chart assuming a normal distribution. We have a mean of 12, a standard deviation of 5, and we want to find the probability that an x value, let's say these were marks on a quiz, that the mark on a quiz is less than 2. Let's say there was 12 questions. Anyway, that doesn't really matter what the variable is, but we want to find the probability that the value is less than 2. All right, so let's just visualize what this means. What does it mean? Okay, so this is a probability. You don't have to draw a graph, but we are going to do it. So we have a bell curve. Let's just draw a bell curve. A normal distribution. The mean is what?
The mean is 12.
The mean is 12. The standard deviation is 5. So within one standard deviation, that's going to be 12 minus 5. That's going to be 7. That's going to be 19. Oh, sorry, 17. Can't add. And then within 2 standard deviations, that's going to be 2 and 22. And so on, right? So this turns out to be, this is x, and if you convert it to a z-score, this would be 0. This would be plus 1, this would be plus 2, This would be -1. This would be -2. Right? If you convert it to z-scores, right? Z-scores is how many standard deviations are you away. All right. So let's just write down the data. The mean is 12, and the standard deviation is 5. If you didn't see the little video on standard deviation I posted yesterday, you should probably take a look at standard deviation. We only talked about it a little tiny bit. It's a measure of spread, but I do recommend you watch that video that I attached in 8.1, yesterday's notes. All right, so what do we do to calculate? So we want to know the probability of x being, like, what's this probability here? Right? So probability that x is less than...
X is less than 2.
Yeah.
Didn't it say z is less than 2?
No, we're talking about x being less than 2. But, so, the first thing is we have to convert, step 1 is we have to convert the x value to a z-score. Well, there's a formula. There's a simple formula. What was the formula? There it is. Pretty simple. Z equals x minus mean over the standard deviation. So, and we actually see it right there. Right? 2 is scored. We can see that. That's my dog. There's a squirrel in the backyard. So we see it's a -2. The value of 2 turns into a z-score of -2. Let's just do the calculation. The x value is 2, right? Probability of x being less than, so the x value is 2. The mean is 12. Standard deviation is 5. And 2 minus 12 is -10. -10 divided by 5 is -2. Let's put some decimals there. -2.00. So that's step 1. Step 2 is find, once you have the z-score, you find probability from z-score. Okay. So the probability that x is less than 2 is the same as the probability that z is going to be less than -2.00. So, can anybody, if you have the chart...
Wait, sir, can you go... Actually, it's okay.
Right, so the next key thing is the chart. How many people have printed the chart?
No.
Anybody?
I have it in front of me, though.
Or if you get page 606 and 607 from the book. So I'll show you how to do it. We're looking for...
Oh, 0.0228.
Yeah, so how did we get it? It's -2.00. So -2 is here, and then the first column is the -2.00 is there. So it's 0.0228, right? So it's 0.0228. We're 20.
So you can't do this without the chart, right?
You can't do it without the chart, no. You can't memorize the chart either. The chart is complicated, so you need the chart. Anybody who does calculations using the normal distribution needs this chart. Okay? You can't do it in your head. All right? All right, that's the answer to A. Let's do B. What's it asking? The probability that x is greater than 40 if the mean was 30 and the standard deviation was 6. You don't have to draw a graph, but I'm going to draw one anyway. Again, we have a bell curve. Right? And this time, the values are going to be, the mean is 30, and the standard deviation is 6. So let's just put in some numbers. Again, you don't have to do all this each time, but in the future you'll probably just skip the graph. You'll probably just go to the math. But I just initially, you know, it's nice to see a visual. So standard deviation is 6. So what's one standard deviation below? That's going to be 24.
24.
2 standard deviations below is going to be, what did I do? I can't even add. Why did I write 23? Okay, 24 minus 6 is... Alright, And then standard deviation above, which is going to be 30 plus 6 is 36, and another standard deviation above is going to be 42. Okay. Again, those are the x values, but the z values, corresponding z values, would be 0, minus 1, minus 2, plus 1, plus 2. All right. And now we want to get the probability that x is greater than 40. So if 36 is there, 42 is there, let's say 40 is there. So it's going to be pretty small. It's a pretty small percentage. Right? So this is going to be the probability that x is greater than 40. All right. So step 1, same thing as before. Z-score equals what? So we want to find the key number is 40. We want to find the probability, so the z-score is going to be equivalent. The equivalent of 40 is going to be, it's going to lie somewhere between 1 and 2. Right? It's going to be like 1.7 or something like that. Let's just see what it is. It's going to be 40. That's the value. And then minus the mean. The mean is 30. All over the standard deviation, which is 6. So that's going to be 10 over 6, which is going to be positive 1.666666, I guess.
So you want to add the decimal?
Okay, I think this chart only goes to 2 decimals. Let's round it to 2. So what is that? 1.67. Okay, 1.67. All right, so the probability, step 2, which first probability that x is greater than 40, right, is going to be the same as the probability of z being greater than 1.67. 1.67. But unfortunately, we only have.
It's only negative.
It's only up to that. We see the z-scores up until that. The probability is up into the z-score, not greater than the z-score. So what do we do if we want to find greater than the z-score? What do you think?
Is the negative of the answer?
Not the negative, the complement. So what's the complement? It's going to be.
Oh, it's going to be 1 subtract whatever that is.
Yeah, 1 subtract. 1 subtract the probability of z being less than 1.67. So you have to do anything that you're doing greater than, you have to subtract, you have to do the complement of, because the chart only shows it one way. All right? All right, so it's going to be 1 subtract, everyone, let's look it up. You tell me what the numbers are.
Can I tell you what I got to?
Yeah. What'd you get?
I got 0.9515.
Let's see. Let's zoom in on this chart here. 1.67, right? 1.6, and then we go to the 7th spot is 0.9525, right? Is that what you got?
Wait.
Is that what you said?
I think I did it wrong. No, I did it wrong.
Okay, 1 point. You're doing it. You got to go to the plus side, not the negative side. So the plus side. There's one side for negative values, one side for positive values, right? So go to the positive page, 607, 1.6, and you have to go over to the 0.07 column. You get that number, right?
So where'd you get that positive one from?
It's on the back. It's on this. That handout is 2 pages. There's page 606.
Oh, okay.
And then there's a backside 607. So one's the negative z values, one's the positive z values. Okay?
Yeah, 9515.
Yeah, 9525, right? So that's going to equal 0.0475 or 4.75%. All right, let's do the last one. What happens if we want the mean is 20? Let me zoom out. The mean is 225. The standard deviation is 20, and we want to find a probability that x, the variable, is between 233 and 254. So let's take a look at that. Let's just draw it. So the mean was 225, and the standard deviation is 20. And you're going to have a bell curve again. Not even, try to draw it symmetric. It's not that great. And the mean is
Wait, sir. I have a question.
Yep.
For the one before, why do you have to do 1 minus?
Because this chart only tells you the probability of being below a particular z-score, not above. So it only gives you this part. There is no chart.
Okay.
Yeah. So if you want to find above, you have to do 1 minus below. Right? If you want to find this area, you want to do 1 subtract that area to get that area. It's the only way you can do it. So I guess they could have set up the chart differently, but that's the way they set up the chart. So it's always up to that certain z point, not z score, not above that z score. All right. So again, we're going to have 1 standard deviation. We're going to have 2 standard deviations. So it's going to be 20. So it's going to be subtract 20 is 205. Subtract 20 again is 185. Add 20 is 245. Add 20 again is 265. And then the z-scores equivalent would be 0, minus 1, minus 2, 1, 2. All right. So we want to find between what and what? We want to go between 233. 233 would be, let's say, here somewhere, to 254, which would be, I don't know, around here somewhere. So we want to find, probability that x is between 233 and 254. Right, which would be that. So what do you think we do? Well, we're going to have to, we have 2 numbers now. We have to calculate z-scores for both. So let's call it z1 and z2. Okay, what would z1 be? Let's say the lower one.
233 minus 225 over 20.
Was it 223?
233.
233. Minus 223, right?
Yeah, minus 225. That's what the mean is.
Oh yeah, minus 225. So sorry, it's 223, not 233. Oh, it is 233. Sorry, it is 233. Sorry.
It's okay.
233 to 254. Yeah, I wrote it down wrong. 233 to 225 over the standard deviation, which is 20. And that's going to be, I think, 0.4 exactly.
Yeah.
Next one's going to be 254. Oh, sorry, which one? Yeah, 254, the x value. Subtract 225 over 20. And that is going to be, I got 1.05. Does that make sense? Yeah. All right. So the probability that you're going to have an x value between
So I got 1.45.
I got a different answer, so let's see what is the prob. So you're going to convert this to the probability that z is between. All right, so 233 corresponded to 0.4, and 254 corresponded to 1.05. So what you have to do is find the probability.
So the z-score for the second one is wrong. It's 1.45. It's not 1.05.
Yeah, it's 1.45.
Oh, really? Sorry.
Yeah.
Not 1.45.
Okay. Perfect. Okay. So then you have to do a subtraction here. So it's one probability subtract another probability, right? So what is the probability of z being? Let's do this one first. What's the probability of z being below 1.45? And I don't know the answer because I punched it in wrong last time. So 1.45. Did you get 0.9265? Right.
Wait, so let me think.
Right. So I'm just punching in the what you have to do this number first. The what is the probability that it's below 1.45? Right. So 1.45.
But don't you subtract 1 from it because it's greater than?
Oh. No, let's just figure this out. So you have a z-score of what is it? You have a z-score of 1.45, and you have a z-score of 0.4, right? And you want, so the first part would be, if you want to find this middle part, wouldn't it be the probability of going up to 1.45, subtract the probability of...
Oh wow, I see the visuals, sir. It makes sense now.
Yeah, so if you take this probability, subtract this probability, you get the probability in between. That make sense?
Yeah.
Okay, so you have to do the probability of getting a z-score of 1.45 first, and then you subtract the probability of getting a z-score of 0.4. So what is the probability of getting a z-score greater than up to 1.45? It was...
So is it? Okay, never mind.
0.9265, right? 0.9265. That corresponds to this guy. And then we subtract the lower limit, which is 0.4, right? 0.4. 0.4 is 0. 6554. So whatever that
You don't
is.
subtract 1 from the 0.4 probability you got, right? You just leave it as the number you find
Yes,
in the card.
you don't have to subtract it from 1 because you're not doing the complement. You are just subtracting two values. Yeah.
Okay.
So it's 0. I don't know what that is because I made a mistake. So what is that answer?
So let me find it for you. 0.92. If someone else can find it faster, you guys can say the answer.
9265 minus 6554.
I got 0.2711.
0.271. Good. Yeah. Okay. So 27% of the time you would be expected to get lie between 233 and 254. All right. Does that kind of make sense? Let's do one more page. Where's the last page?
So isn't that it?
Isn't there one more page? Don't you have this? Do you guys not have this?
I have it.
All right. So let's finish. Krishna, you have it?
Yep, so I found it. We're good.
Okay. What's the time? How long is this video so far? How long? I don't know. I can't see. Okay, well, I'm going to keep on going. All right, on last year's data exam, the mean score was 70% with a standard deviation of 8%. If Charlie scored 62%, determine his percentile rank. So we'll figure what that means. Let's just draw a quick graph. Again, when you have small populations, maybe the normal isn't that accurate. But if you have a big population in the thousands, in the millions, normal's pretty accurate model. So the mean is 70, and then we're going to be one standard deviation above is 8. So it's 8%. So it's going to be 78. This is going to be 62, and then plus or minus another one is going to be another 8%, so that's 86, and what the heck is that, 74? Oh, sorry, 54. Alright, so again, that's your x, and then corresponding z values are 0, minus 1, minus 2, 1, 2. Alright, so somebody help me out here. What do we do? What's the first thing we do? Step 1 is we don't use the x values, we use the z values. So we have a score of 62. Oh, so the z score is pretty easy, right? We can see it right here. The z score is minus 1, right? But let's just show it. Z score is going to be 62 minus 70 over 8. So yeah, mathematically we get minus 1. So again, we have to convert the probability of the value being less than 62. It's the same as you have to convert this to z score. It's the same as the probability of the z score being less than minus 1. And that is, somebody look that up for me. What is it using the chart? Some of you have the chart, right? So minus 1. What's minus 1? Minus 1 exactly is 0.1587. Or 15.9%, whatever. So when it's asked what the percentile is, what does that mean? What does it mean? So Charlie's down here, so 0.1587 of the people who wrote the test are below him, right? 0.1587 of the students that wrote the test are below him. So what would be the answer to the question? Charlie is in the blank percentile. It would be the 15th. Right?
Why the 15th?
Because it just converts this to percent. So, so 15.87% of the people are below him, right? Not quite 16. So he's in between 15 and 16. Like, you have to round down, right? So this as a percentage, this is 15.87. He's in between the 15% and the 16% of the people, right? So you would count that as the 15th percentile. The first percentile goes from 0 to 1. The 15th percentile goes from 15 to 16, right? So the 15th percentile is 15.87 is between 15 and 16. So he's in the 15th percentile. So that's what percentile means. Again, normally when I teach this part of the course, we've already done the stats part of the course, so I haven't taught that yet, but that's what percentile means. Let's do one more. The average heights of teenage boys are normally distributed with a mean of 170 centimeters and a standard deviation of 15 centimeters. What range of heights could occur about 80% of the time? So we're going to say this is the middle 80%. So now we're having percentages, and now we're trying to convert it to x value, like to value. So we're going, we're kind of doing something a little bit different here in this question. Let's just draw a visualization. Again, we're going to draw a very quick bell curve, and we have this height in centimeters. Let's just draw a standard deviation of 70. So this is in centimeters. So one standard deviation is going to be 15 higher. That's 185. Another one is going to be at another 15. That's going to be 200. And then one standard deviation below is going to be 155, and another standard deviation below is 140. Alright, so that's the x values. The corresponding z values are minus 2, minus 1, 0, 1, 2. So we want to find the middle. We're going to assume that's the middle 80%. So we want to go from, I'm just going to I don't know, let's do something. The middle 80% would be something like this. We have little tails on either side, right? That makes sense? So the middle 10%, if we were talking about percentiles, what percentiles would that be from? So if we have 80%, the middle 80%, what percentile did we leave out here and what percentile did we leave out there? If 80% on the middle, what are the two ends?
10 to 90?
Yeah, it's going to be 10% here and 10% there. So it's going to be from the 10th percentile, that's the lower half, and then the top half is from the 90th to the 100th. There's going to be 10% of the people here. So from 10th percentile, from 10th to 90th percentile. Right? All right, 10th percentile. Well, just as we did earlier, that just corresponds to a z-score. The 10th percentile equals 0.10. So, right, the area here, this is going to be 0.10. But what is the z-score, right? Now you have to work backwards. We have to find out what the z-score is. So what is the corresponding z-score? Corresponding z-score.
Sir, can you wait? Never mind.
Okay, so we have this time we have the area. We're trying to find the z-score. So now we have to find the z-score, which normally we found the z-score, then found the area. Now we find the area. Now we have to do it backwards. So 0.1. Where the heck is 0.1? So which number? Here is 0.1? 0.1. 139, 107. What am I doing here? Is that the closest one? Oh, right here. Between. Which one are we going to choose? Minus 2.32 or is it 2.33? What am I doing? 0.10. How come corresponds? In my notes I got minus 1.28. Oh yeah. Here I am. This is 0.01. Yeah, 0.1 is over here. 0.1. Which one's the closest one? Right there, I guess. Right. That's closest to 0.1. Oh, can you see that? Right. That's the closest one to 0.1. So that's going to be minus 1.28 is the corresponding z-score. Right. What about the 90th percentile? Can you tell me what the corresponding z-score would be for that? Can somebody look that up? So now we're at 0.9. Where the heck is the closest one to 0.9? Would it be that one or that one? Here we're 3 10,000ths away. Here we're 15 10,000ths above. Which one should you take? Be this one, right? This one is closer than that one. So it'd be 1.28. Right? Which makes sense, right? It's symmetric, right? We didn't even have to do it. Once you got if it's the middle, then it's got to be the exact same thing on the other side. Right. So what is the area? What are the values? So what does a z-score of minus 1.28 correspond to? What value does that correspond to?
That corresponds to around roughly 190, 192. That's positive 1.28.
Oh yes, okay. So let's do that. Yeah, you're right. So I got a little bit less than that, but okay. But let's.
I was just guessing.
Oh, okay. Let's do the lower one. So let's do this one first. Okay, so we're gonna. So the z-score, we know the z-score minus 1.28.
Oh, you want the actual calculation?
We want to find x this time. So x, we're trying to find x. The mean is 170, and the standard deviation is, what the heck is it again? 15. So somebody solve this for x. What is the value?
So I'm gonna solve it right now.
You do that right now. It's pretty easy to solve. So multiply both sides by 15, and multiply by 15 and subtract.
150.8. So I was close, I guess 150.
Right. So on the lower limit, we have a height of 150.8 centimeters. And on the upper, so this is the lower, and this is the upper. So again, now we're going to do plus 1.28 equals x minus 170 over 15. So if you do that one, you're going to get, what do you think? Somebody want to do that? Give me the exact answer.
189.2.
Yeah. So therefore, 80% of the boys will be between 150.8 centimeters to 189.2 centimeters. Okay, that's the lesson. Let me just pause the video here. Where is it?